Okay, hello everyone. I'm very sorry. We've had a little bit of technical difficulties in the beginning, but we're all here now, and thank you very much for joining today's webinar. Today's Softtree's webinar today will be on working with drone data in our Train to 3D software. My name is Andy, your host, and we have our house engineer Emmanuel with us to present the webinar. Just a few comments before we get started here. For those of you who are not familiar with Softtree, what we offer is an easy-to-use software tool for engineering, such as road and site design. We've chosen Pix40 for this demonstration because we've recognized that it's a popular software package for drone data processing. I do have to make a disclaimer here that we're not experts in this field, and we're not associated with Pix40. What we do is engineering software. The data we're using today is a sample downloaded from the Pix40 website, and we've been given the courtesy by Pix40 to use the data for this webinar. And I'm just going to continue to the next slide. Okay, so a bit of webinar housekeeping items. You are muted, but please feel free to ask and engage questions with us through the Q&A section of the GoToWebinar panel. And this webinar is being recorded and will be available on our YouTube page. So all of the registrants, even if they have not attended, even if they're not attending this webinar as they are, will receive an email link to the recording. Okay, so what's on our agenda today? So we're going to be starting with importing, so Emmanuel is going to start by processing the given data in Pix40 Mapper, and he's going to import the data into Softtree's Train to 3D program. He's going to create a 3D digital train model with the data, and we're going to be presenting some of the grading features that's available in Train. And we're also going to show how some of the earthworks can be calculated. And he's going to continue on by importing some geo-referenced images into the background. And he's going to finish up by drawing an alignment in the train module. So without further ado, I will now pass over the presentation to Emmanuel.
Yeah, sorry, just give me 1 minute. I want to switch to my screen. Okay, hello everyone. My name is Emmanuel. Today we have another webinar for working with drone data in the train models. Over the past few years, Softree has seen a significant increase in customers using DEM data and imagery acquired from UAVs, commonly referred to as drones. And this form of mapping has a wide range of applications, such as surveying right-of-ways, prior after filling and prior to construction, construction monitoring, and as-built surveys. So for first step, let's open the Pix40 website software. I'm going to open the version 4.5. I already download one of the examples that they have in their website called Cadast Pix40. That's an area in the Switzerland that they did some surveying in this area. Let's check what we can do in the software to export the LAZ file and the georeference image that we need in the train model. So for first step, I click on the processing options icon, and I check these three items: initial processing, point cloud and mesh, and DSM, orthomosaic and index. As you see, I want to select LAZ and LAS type, and I want to also merge all of the tiles into one file. We have a very important option here. We can classify different point clouds in the Pix4D And fortunately, train model is able to recognize different layers as well. So different clues like, for example, points in the ground layer, high vegetation, low vegetation could be classified in different layers. I also want to have a geo-reference image file to use it as a background for my project. And yeah, just I want to click OK. Yesterday I could download these files and started processing the data. I think it took almost 4 hours, and now we have all processed data and we could start exporting data to the appropriate format that we want. So to do that, I click on the Ray Cloud button, and then I check the point close item and also the display properties. So we could see that Pix4D is processing the data. Let's take a look at the 3D shape of the project. Here we have some stations that the camera already had a survey and complete we had a complete survey for different stations by the camera, and we want to export this surface as a LAS or LAZ file or as a georeference image. So to do that, I just right-click on the example, Cadast, and click on the Export Point Cloud button. Here, it's possible to select those layers of points that we want to have in the LAS and LAZ file, and here is the final destination folder that I want to save my file. I already saved this file, and I just want to select this folder again. Yeah. Okay, let's click OK. Pix4D is exporting data. Now we have time to open the train module. Version 9 is the latest version that we have in the train module. It's released at the end of the last year. I think Pix4D is still exporting the files. Yeah, before importing this file, let's take a look at different types of the files that could be imported into train module. Train module is able to import ASCII files, CSV files, shape files, and a land XML file. But right now we want to use the LAS LiDAR format. For that, to see, yeah, I think the file is completed and we could use the LAZ file here. So I click open, and I want to see the points on the screen, so I tag the display points item and I click on the examine files button. So train module start classifying points in different layers. Those layers that we had in Pix4D will be seen here. Yeah, we could see that in the ground layer, we have almost 10 million points. We have low vegetation, high vegetation, building, and reserve. For first step, let's import ground layer. And I want to reduce the number of the points because right now For the live webinar, I prefer to run processing and generating the scene faster. So I select level 19 and I can see the number of the points after thinning. That would be almost 500,000. I already checked the location of the project in the Pix4D website. That's an area in the Switzerland, and in the UTM coordinate system, the zone number is 32N. So in the projection tab, I select the UTM zone 32 and I click OK. By the way, if you have any question regarding different items that we are presenting in the webinar, please don't hesitate to send us your questions. Yeah, here we have the points in the ground layer. At the bottom of the window, we can check the total number of the points. That's 530,000. Even after importing, if I want to reduce the points again, I can go to Train Modeling tab and click on the Simplify button. And again, by changing the spacing number, I can reduce the number of the points in the plan. But let's keep these points. For next step, I want to generate a teen model. So I click on the Generate button and let's select contours because I don't want to have any contours on the screen. And I click OK. Train model is processing the triangles, and to see the 3D shape, I click on the 3D button to see the 3D surface. Yeah, here is the surface that I created just by using the points in the ground level. Let's save as this file in a separate TERX file. I already created this file, so I just want to save as this file and replace it. Yeah, but after I import these points, it's possible to again insert or import other layers to see the location of the other points on the screen. Suppose that I want to see the points in the layer, in the building layer. So I go to Home tab, click on the Insert File, and again in the LAZ file, I click on the Examine File button. But this time I want to select a building layer instead of ground layer. And the train model is examining the file to check different layers in the file. Yeah, let's select the building layer. Again, I want to tag the display points item to see these points. And this time I want to select level 9 to have almost 300,000 points on the screen. And you can see that in the projection tab, train model already set the coordination system according to the existing file. So there is no need to change anything. I just click OK to see the points that are in the building layer. Yeah, after tuning the point, we will have almost 300,000 points in the building layer. Yeah, here we can see the location of the buildings and the roofs on the plan. If I click on the 3D bottom, I can see these points better that we have it in the file. It's possible to create a surface by these points in a separate file, and then we can compare different surfaces and calculate the volumes between these surfaces. I can also import other layers, but let's right now uh, uh, go to plan again and see what are the options and useful tools that we have in the train model. So I want to open a new file in the train model. I don't want to save this file. Yeah, and now I want to use the TRX file that I created, and I call it ground.trx as a background. So I right click on the screen, and in the background tab I select this file. Let's click OK, so we can see the ground.trx file that I just created as a background. Let's do some grading like this. Uh, to do some grading, I go to Home tab and click on the New Feature item. I want to start drawing a feature. I call it Path, and I want to set the elevation. I already checked the elevation of the points. I know that the elevation that I need should be almost 880, and I click OK, and I start drawing a feature in the plan. Yeah, let's start drawing the feature here. Yeah, here is the feature. Let's change the thickness and color of this feature so we can see this feature better on the screen. Yeah, here is the feature, and I want to use this feature as a top surface of this path. I can also check the location of this feature in the 3D window. But to do some grading, I just click this feature, and I go to Train Modeling tab and click on the Grading button. And because the direction of this feature was clockwise, and I want to do some grading on the left side, I check the left icon in the orientation area, and then in the target surface, we could see all of the surfaces that are defined as a background surface. So I choose the only background surface that we have, and let's keep the slopes to 1:1, and also I want to change the spacing for the slope lines to 10, and I want to generate a theme and also calculate the volume for this path. So I click OK. Yeah, here is the volume. The total volume of the cut is 3900 39,000 cubic meter, and we could see also a nice picture of the pad here in the 3D window. Of course, you can change the elevation of the feature or slopes uh, um, of this pad. This is a nice option that we have in the terrain modeling, that we could do some grading for different layers in the uh, uh, file. So as I mentioned in the beginning of the webinar, and terrain model is also able to import the georeference image files. So again, let's delete these points, and I go to the plan window. I click on the zoom extents to see the points here. Let's check that still we have ground file on the background. Let's open a new file and use again that file as a background. Oh, I think maybe I have deleted that file, but anyway, let's open the CADAS file again. This time I'm gonna import another layer. We have points in the on the roads in the reserved layer. This time I want to import these points into the terrain module and then use the georeference image file as a background for that. So I'm gonna select reserved layer in this step. Yeah, and I check the display points option again. Let's set the resolution level to 99, so totally 48,000 points will be imported. And again, I should set the projection tab and zone number to be 32. And let's click OK to see the points that are on the road. Train module is reading the points and processing data to reduce the resolution level. Yeah, here are the points that we have in the reserved layer, that are the points basically in the roads. In the file, to insert the georeference file, again I go to Home tab and I click on the Insert File button and I select the GeoTIFF file that's in my folder. We have two different formats for these files. We could select the first one that includes the georeference image file, and also we have USGS right now let's select the first one. As you see, train model automatically has recognized the reference coordinate for this image, so there's no need to change anything here. I can increase the image quality to high, and of course you can change the washout level. And in the projection tab, automatically, as you see, the train model has set the zone number to 32N. And yeah, I don't want to change anything, so let's just click OK. And then I should click on the Apply Transformation. Yeah, the train model is loading the image file. Yeah, here is the image, and as you see, the points in the reserved layer are exactly in the area that we have roads. It's a very nice option that we can use these georeference image as a background to have a better understanding of the location of the points in different layers. Now, if I go to Train Modeling tab, I can click on the Generate button to create a surface. Again, I want to unselect labeling, and I want to have any major or minor contours, and let's keep the maximum side length of triangles to 5. So I click OK, and then I can see that a 3D surface is created by the points that we have in the reserved layer. So let's start drawing an alignment. I go to Home tab and creating the new feature. I call it CL. It could be a center line for my road, and I want to have a draped feature so I can use the elevation of the existing surface, and there is no need to define an elevation for different points. I click on the mouse button and I start drawing a feature on the screen. It could be a center line for my road. Let's change the thickness and also the color to red. Yeah, here is the line that I just created. Let's check the location of the line in the 3D window. Yeah, this is another option that we have in the train model, that we could import different layers, create a surface for these points, and we could start drawing a feature or an alignment for the road, and then I can use the location model and export this train file and also the existing feature center line, and use the location model to uh, continue designing of the road. Okay, everyone, uh, this was our webinar for today. We tried to present the Pix4D mapper software. That's one of the professional drone mapping software in this area. And also we try to present the abilities of the train model to import different layers and different options that we have to reduce the number of the points, and also generating a team by these points. Thank you very much, and hope to see you in the next webinars.
Okay, well, thank you very much, Emmanuel, for the presentation. Now we have some questions on our Q&A panel. The first question is, does Pix4D come with Softtree v9, or do we need a separate license? So the answer is yes, you do need a separate license of Pix4D. Softtree or Train Tools or RoadEng is not affiliated or associated with Pix4D Mapper or Pix4D.com. So the answer is yes, you would need to look into a separate licensing with Pix4D. We're just an entirely different company. We don't do post-processing with drone data. We provide engineering tools. And the next question goes into, and this is a question for Emmanuel. How many points can Terrain Tools handle in one file?
Yeah, actually, that's a very good question. We recommend for train modeling purposes the number of the points to be under 10 million points.
Thank you very much. And I think we've demonstrated this in the beginning, but the next question is, can can users trim or thin the LiDAR data on unimportant areas to reduce the file size?
Yes, of course. Train module has the ability to thin the points in different areas. And of course, the thinning level could be different in different areas in the file.
Sounds good. And I think we're down to 2 more questions, and we'll just see if there's any more. But the next question is, can you save surface data from terrain and then to import into other software like Esri or AutoCAD?
Yeah, absolutely. The train model is able to export files into different formats like land XML, shape files, or DWG files. So when we import different LiDAR data, like here, we could export these points in a different format and use it in the other software.
Thanks for that. And the last question that I'm down to is for elevation data, is working with LAS or GeoTIFF format, which one's better?
Basically, using LAS file is better because when we generate a thin, the thin will be more accurate, and usually the process would be faster when we were working with the LAS file.
Okay, as there seems to be no further questions on the panel, and if you do have any questions, just please feel free to just email your questions to Softree's support email, and then we'll make sure to answer those questions in a timely fashion. Okay, well, thank you very much, everyone. Hope you enjoyed the webinar, and see you next time. Bye now.